Today we're going to be solving outboard engine problems. We've got a 2018 Mercury 150, a Yamaha F150, a Suzuki DF50, a 2001 Mercury Optimax 225, a 1980 Johnson 85, a 1996 Yamaha, and a few other engines that all have individual issues that we're going to kind of discuss through what the issues are, what might be causing those issues, are they catastrophic, are they fixable? We'll go over each one of these comments in detail today. And to begin, we want to thank our show sponsor, Partsview.com, for bringing you this podcast and allowing us to answer these questions in this type of a format. They are a marine parts and outboard superstore. You know, they do have those 20, 100, and 300-hour maintenance kits that are all packaged conveniently for you to fit your specific engine model, but they also have safety gear and docking supplies and other things that you might not think about that you could need for your boat. You can get a discount if you use the coupon codes and the links in the description below. So our first question is going to be from Tiffany Collins. We've got a problem with our 2018 Mercury 150 four-stroke engine. We've had it for 2 weeks and have had it on the river twice and it won't start. We've replaced alternator, plugs, etc. Took it to Bass Pro and the flywheel has no play and won't turn. Any help or info will be appreciated. We are so aggravated and need a little help, please. Tiffany, I do apologize because that is not good. So there are really two different things that could be happening here with a flywheel that doesn't turn. So the alternator and the spark plugs, all that stuff, that has nothing to do with the flywheel itself. If the flywheel itself does not mechanically turn, and I'm surprised if you took it to Bass Pro that no one went further than just saying that the flywheel won't turn. But if the flywheel of the engine will not turn, that means two things. One, the engine itself mechanically, being the crankshaft, your pistons, inside of your cylinders, the connecting rods, all that stuff, that will not mechanically turn. That means it's got, something has happened where it has locked itself up. Or two, the better option, and hopefully the problem that's going on here, is that the lower unit is locked up. So you've got something going on with the lower unit, and the lower unit itself, even though that's not good, that's a catastrophic issue. And on a 150, I'm sure it's a $5,000 lower unit. So that's not good either. But at the same time, if you pull the lower unit, and in the lower unit being locked up will not allow the crankshaft and the flywheel to turn, then there you go. That's your problem. So hopefully it's not the actual power head itself. I'm surprised that no one went any further than just saying that the flywheel won't turn, because that's like, as soon as you get to that point, this is catastrophic territory. Right now we're talking, this is either the power head's locked up or the lower unit is locked up, one or the other, and it's not good. It's a big deal. And so I'm surprised that no one went any further than that. The alternator and the plugs, that really doesn't have anything to do with it. Using the engine twice, that's unfortunate, but that is unfortunately the situation there. When the flywheel doesn't turn on any engine, it's either one, the gear case is locked up, or two, the engine itself has failed and it cannot mechanically turn. So I am sorry about that one. That one being the first question and the first comment, potentially a locked up engine. So not good. And Stephen Young. So you've got, I hit a big wave and lost power, but I'm confused because it idles fine. You can rev it up in idle. It's not getting hot or it's not smoking, but when you put it in gear, it just loses power and dies. Most likely what's going on here is you didn't tell us what engine you have. So, we're going on a guess of what this is, whether it's 2-stroke, 4-stroke, a big engine, a small engine, a 6-cylinder, an 8-cylinder, a 2-cylinder, there are lots of variables here, but generally on an outboard, if you put it into gear and it just loses power and dies, that is usually a cylinder issue. So you've got kind of multiple issues, I would say, here, and that being that whenever you take an engine and you shift it into gear, it does what's called a shift cutout, or it drops out 2 cylinders or 1 cylinder, or depending on the engine model, to make it easier to shift. So when you've watched the videos about how a lower unit works, you know that inside there is a clutch dog that engages with a gear. So when you shift it, that clutch dog engages with a gear. When the engine is running, the clutch dog is spinning and the gears are spinning. So if you were to just try and put that in there, the faster they're spinning, the harder it is for them to go into place together. So what they do is generally you never shift it at high RPM. Like, old Johnsons, that's a different thing. Some of them have high idle RPM because it's just the way they are, and you slam shift them, I guess is what you would say, but that's not good all in of itself. You want to shift the engine when it is at idle. If you're at 1,000 RPM, 1,200 RPM, 1,500 RPM, anything other than idle, it's not good to shift it because your gears are spinning the same speed as the engine depending on the gear reduction of the lower unit. So on a lower unit, you have what is called gear reduction, meaning that the gears in the engine have a different number of teeth and they spin at a different rate than the crank or the engine itself. So if the engine, let's say it's a 2-to-1, if the engine is spinning at 2,000 RPM based on a 2-to-1 gear ratio, the lower unit prop shaft is going to be spinning 1,000 RPM. So it is going a little bit slower. So if you're running at 600 RPM as your idle or 800 RPM, when you shift it, the gears in the lower unit are running at 400 RPM. Now, whenever you shift it, it cuts out a cylinder or 2 cylinders depending on the model. So let's say it's a 6-cylinder and it cuts out 2 cylinders. I mean, it's a brief cutout. So when you shift it, it drops out 2 cylinders, which drops that RPM. And when that RPM drops, let's say it drops from 800 to 600. Again, these are all general numbers because we don't know what engine you have. We don't know anything about other than that. When it drops that RPM to 400, that drops those gears down to 200, or 600 drops down to 300. So at 300 RPM, it's a lot easier for those gears to go into place. But I'm saying all that so you understand what's going on, because whenever you shift it and it dies, if you've got a 4-cylinder and it drops out 2 cylinders whenever you shift it, if there is a problem with one of those cylinders, like let's say that it cuts out cylinders 2 and 3, right? And normally when you shift it, it runs on 1 and 4 for a brief moment. If there's a problem with cylinder number 1 being a bad spark plug, it's not getting fuel, anything, no spark, it could be anything, a problem with that cylinder, and you're really running on 3 cylinders, not 4 cylinders, whenever you shift it and that cuts out those 2 for you to shift it, that means that engine is running on 1 cylinder. And if it's running on 1 cylinder for that brief moment, it'll usually die out because you shifted it and you cut 3 cylinders basically in a 4-cylinder engine trying to run on 1 cylinder. That is a very, very common issue. So most likely you've got a problem with, hitting the big wave and losing the power. That could be irrelated or it could be related. So at idle, it seems to run fine because it's running on 3 out of 4. It's probably got a little bit of a vibration, maybe a little bit of a hiccup in the RPM, but depending on the model, if it's a 4-stroke, the 4-strokes are controlling the RPM and the idle. They have idle speed controllers and other things on them to maintain a smooth idle. And at a smooth idle, you won't be able to tell if you've got, a bad cylinder unless you know what you're listening, feeling, and looking at. The random recreational person that isn't really mechanically inclined and doesn't have a ton of experience with engines probably would never even tell that you're not running on all cylinders, or you wouldn't be able to tell there's a vibration or something like that, depending on how bad it is. So that's probably why I would say most likely you have a problem with one of the cylinders, and that's why it's cutting out. And hopefully, if you hit a big wave, it might just be a connection. So let's say it's the plug on the fuel injector or the ignition coil or something like that, and that plug has come loose, or something related like that. Because if you come down on a wave and the plug to the injector wasn't on there all the way, or whatever the situation may have been, if it came off, now you're down that one cylinder, you go to shift it into gear, boom, now your engine's going to die because of that cylinder. So most likely you have a problem, a running issue, something that's going on that you didn't notice that you had previously to hitting that big wave. And maybe they're related, maybe they're not, but most likely you have just a normal, common running issue, bad spark plug, clogged injector, whatever it may be, that you didn't really notice that you had going on. And now hitting that wave, it exasperated the problem. And so now you're actually noticing and seeing it because the engine won't run. So that's that'd be my guess first there. Jay OBGYN says 2001 Mercury Optimax 225 XL jumps from 580 to 1180 after an inch of no response. Changed everything up to the TPS. Nobody else seems to have this issue, ? So if you are jumping that much, that far of a gap from 580 at idle all the way up to 1200, most likely, so you've changed everything up to the TPS. So when you say that, I'm guessing that's control cables and all that stuff. So whenever you move your throttle and you're moving it forward, it is moving that control arm that is changing your throttle arm. So it's changing the throttle body and all that stuff. So if it just jumps that big of a gap, most likely there's something wrong with the TPS. So I would be realistically, that would be the first thing that I would look at. You would take the control cable off of the throttle body or the throttle arm or the throttle controller, whatever you want to call it, and you would shift it and throttle it and make sure that the cable is moving congruently with your handle. So as you move the handle, you want to make sure that throttle cable doesn't have any play. You could also even look at the throttle cable because most likely, granted the TPS I said would be the first thing I would look at, but that's just first after doing the basics. In my mind, I'm trying to process it, and I would look at the throttle cable first and look for play. So disconnect it from the throttle arm or throttle controller and try and move that cable back and forth. How much play do you have in that cable just moving it by itself? If there's a bunch of play, there you go. That's going to be your problem, is that you move your handle, and as you move the handle, that play in the cable is not moving your throttle arm because let's say you've got a 1/4 inch, 1/2 inch of play. As you move it, you're getting the play out of the cable, and then boom, as soon as the play is out of the cable, it's either pulling or pushing your throttle arm, and that is now initiating your thing. But I don't think that would be the issue with this, because even if that was the case with the throttle cable, it would be a smooth transition in your RPM from 580. It would smoothly go up because the play is in the cable. So that's not going to be it. When it jumps that much RPM, that's usually something to do with the TPS or something like that, because the TPS is what helps to control the timing. Your throttle position sensor, it's telling the computer where the throttle plate is, and based on where the throttle plate is, it tells everything else how to work. How, your fuel injector duration, your air injector duration, the timing of the spark for your spark plugs, all that stuff is based on the position of the throttle plate. If it jumps from 580 to 1180, that's 600 RPM. Jumping 600 RPM would say that the TPS should be a smooth sweep. If it's not a smooth sweep and you jump from here, like the way a TPS works is it's basically a 5-volt sensor, and from say a 1/2 volt to 4.5 volts of electricity, that's its range. So at idle, let's say it's 0.5 or 1/2 volt. At 700 RPM, it's 0.7. At 1,000, it's 1 volt. At 2,000, it's 2 volts. Granted, those numbers are going to be changing, but if it's jumping from, say, 580 to 1180, jumping 600, that means that it's going from 1/2 volt all the way up to 1.2 volts. And that's what it's telling the computer, and the computer is instantly changing from idle to that higher RPM. So I would say it is something going on with the TPS, but lots of other things could affect that. But generally a jump like that is going to be TPS related because it's a computer controlled engine. So any quick jump like that, throttle cables, like we said, would be smooth transition. So jumps, probably the TPS or something related to that. Without hooking it up to a computer or testing it, you're not going to know. Shelton McMillans says, I have a 1980 Johnson 85 horsepower, older than me, that has an intermittent problem. I can be cruising down the river and it's like someone flips a switch and I lose half power and the engine bogs. Just as quick as it starts, it stops. I replaced the power packs, ignition coil, and spark plugs and still have the problem. Any thoughts or advice would be greatly appreciated. Thanks. So definitely not an expert on a 1980 85 horsepower Johnson, but a lot of those old two-strokes are very similar in the way they function. And you've said two big things is that you've changed out your spark plugs, your ignition coils, and the power packs. So you've actually kind of gone in reverse of what you would really want to do when diagnosing a situation like this. So generally, the spark plug is the last in line of what controls the ignition on that engine or on any of those two strokes. I'm going to try and get basic with it. I'm not going to go into individual models of this. So like generally you've got the flywheel that has magnets on it. Those magnets go around a stator and the stator is what produces the power for the engine to run. It also is going around and triggering triggers. So your triggers, your pulsar, your crank position sensor, depending on the model and the make of it is what it's going to call that. But that's what tells the power packs to then collapse your ignition coils to then fire on the spark plugs. So you really want to start at the beginning of the system, being the flywheel and the magnets and the stator, the triggers, all that stuff that is feeding your spark plug, ignition coils, and the power packs. So you kind of went in reverse as far as your troubleshooting diagnostics. You needed to start from the beginning of the process, and especially on a 1980 Johnson 85, most of those Evinrude and Johnson are notorious for having issues with flywheels and their magnets. I mean, like, it's amazing that even the newer Johnsons and newer Evinrudes, I mean, I call them the same thing, but they've even had problems with the flywheel magnets, like where the magnets are they're coming off. It's like, I mean, how have you not figured this out so far? But they didn't. So what it is they also make an epoxy. So you can get an epoxy from them and you mix it up and stick the magnets back on the flywheel. But the magnets are spaced apart and they also have poles. You have a north and a south pole on a magnet, and based on that, when that goes by, whatever it's triggering, it creates a magnetic field, which creates the electricity and blah, 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 blah. But if those magnets move, which is what would happen a lot of times on engines like that, they would get hot, and the epoxy that holds the magnets on the flywheel would either melt or it would just fail, basically. Let's say it's a failure. Then the magnets would move. That would throw off everything on the ignition system because now the engine, it's not making the right amount of electricity, and it doesn't know where it is because the magnets are all moving around. The engine has no idea what's going on or your power packs have no idea what's going on because the triggers, being the magnets, everything's all messed up. So lots of different things there. Also on some models, Johnson's, not the 85, there was timer base assemblies where same thing, that epoxy that's on the stator and the flywheel magnets, all that stuff, it would all melt, get down on the timer base and mess all that stuff up. So my guess is that stator, trigger, flywheel magnets, something like one of those components is really what your problem is because it is an electrical timing issue. It is very instant. So like it's either running smooth, and then a magnet moves or whatever, if there's an issue with the trigger or the stator or whatever, as soon as it gets hot, whatever the issue could be, boom, it instantly messes up. So that's why you'd be running along, having no problems, and then just boom, it would bog down, and then all of a sudden it would come back and everything was good. And that's because the resistance or whatever it may be, depending on the problem, it came and went. It's very instant like that with electricity. So you kind of started the wrong end there. I'd go back and check, pull the flywheel, check the stator, check the triggers, check the flywheel magnets, all that stuff. And then Joe says, I was wondering if you could help me diagnose my old 96 Yamaha. I was running offshore one day and my motor died quite suddenly. It was accompanied by a loud chattering noise. I wasn't sure if I blew the motor or had flywheel issues. I tried starting the motor several times, but the flywheel was locked up, so I would give it a slight turn and the motor would try to start up again, but it would immediately seize. Not good. He's also got some videos here. So yeah, this kind of goes back and links back with our first question about, being the flywheel not turning. And for this one, it is kind of hard. I mean, it sounds like it's in the power head. So either whatever failed, I don't know what failed, detonation, pre-ignition, the piston, the connecting rod, something is mechanically failed on that engine. And it could be the lower unit that is making that sound, but at the same time, it kind of sounds like there is something wrong with one of the cylinders, and that is unfortunate because that goes back to the first comment, and it kind of sounds like a catastrophic failure of something mechanically on the engine. So unfortunately, Joe, I'd be spark, compression, and that's it. So I'd do a compression check and make sure that mechanically everything's going on. And as long as you got compression, then I would be looking at that lower unit and seeing if something blew up. But, that is unfortunate, Joe. I do believe that you are going to be in the market for either a new power head or a new repower or a new engine. So yeah, that's unfortunate. Sorry, Joe. Alexander Tyson says, after repairing an issue with our 2005 Fountain 32cc center console and twin 2010 300 AMS Verados that encountered galvanic corrosion issues, the port engine will not turn on. Message says port engine critical engine actuator is low through the Simrad diagnostics. The diagnostics shows starboard is in neutral, the port is in reverse, despite both the engines are in the neutral gear position with oil filled. The DTS throttle unit shows green on the right side of dual throttle, but turns green on left and turns off immediately. We ran a clean power with new fuse into the port engine, but continues to blow fuses every time we place a new one in using the required fuse for the harness. Is there a cable that needs to be connected to the helm in order for it to start? What cables should we be looking for at the helm? Anything else I would be aware of going forward? So Alexander, you've got a big issue here. So I wouldn't be looking at anything at the helm, honestly, because we're talking about galvanic corrosion. That means that you've most likely went in there, you've had to change trim, drive shaft housing, you've probably pulled the power heads and the motor mounts, all that, if it sounds like what's going on is everything on the engine has been pulled apart and put back together, basically. So I wouldn't be looking at the helm of the boat, because the helm of the boat, nobody touched anything up there. First problem is that it's blowing the clean power fuse. So something is messed up. Something's not right. Something's hooked up incorrectly. Something is smashed. Something is shorted out. I don't know what the issue is, but I wouldn't be looking at the helm. I'd be looking at the engine itself. Sounds like the starboard is all good. So what I would do is that on the 14 pin of the engine, I would disconnect that 14 pin. That's because that is what connects the boat to the engine. And I would remove the boat from the engine, so that way you're only looking at the engine. So now starboard engine, the helm, all the harnessing in the boat, all this is now over here. We're only looking at your port engine. On the port engine, I would make a shunt tool, which is something that connects the A and the C port on a 14-pin connector for Mercury, which is basically just telling the engine that you're turning the key on. On a Verado, because it is an AMS, advanced midsection, it is got everything's digital. It's a digital engine, digital throttle, digital shift, digital control of the engine on everything. So it has to have clean power for the computers to turn on. So you need to do exactly like you did. You added clean power to the engine, and now you take that shunt tool that you make to trigger the engine and basically trick it to tell it that you're turning the key switch on. Whenever you hook that up, the fuel pump should come on and everything should come on the engine. If you blow that fuse that's in the clean power, that means something on the engine's messed up. I would then, you're going to go through some fuses here trying to figure out this kind of an issue, but I would take out all the fuses from the fuse panel on the engine, meaning your start, your main power, all that stuff. Pull out all those fuses, put your clean power, and hook up your shunt tool. If it blows that clean power with all those fuses out, that means you've got a problem with something before all those fuses. So either your ground cable, your power cable, the clean power itself, maybe the clean power and the power for your battery cables coming to the engine, something there is messed up, and that's what's blowing that clean power fuse. Without getting the computers to turn on, you're never going to get anything to happen. It's not going to start. It's not going to shift. It's not going to do nothing from the helm because the engine itself the computers never have power. As soon as you turn power on, it blows the clean power fuse, which means the computers no longer have power and the computers are not turning on. So if it doesn't blow the fuse, now you just need to go through and start putting your fuses back in one by one into the start circuit, into the trim circuit, into the ignition coils, into the ECU or ECM or PCM, whatever. That's kind of what you need to do, and go through all those fuses until you get stuff to stop popping. Like, you need to figure out what's crossed, what's bad, what's shorted, something is messed up that's blowing that clean power, and you got to figure that out before you can do anything else. So that's kind of what I would do. Forget, I guess it does sound a little bit more complicated than it really is. Mainly because you're looking at the whole boat. You're looking at the handles. You're looking at the starboard. You're looking at the port. You're looking at all the wiring in the boat. You're looking at the handles. You're looking at the air codes. Like, none of that stuff matters. Go right to the issue, and that's that clean power blowing, and you got to figure that out. And then once you figure that out, then you can go on to looking at anything else other than that. So that's going to be where I would start, is figure out why that clean power is popping and fix that problem first. Alan Burner says, about to take apart my VST tank. Fuel seems to be coming from under the brown plastic connector, blue wire. Any ideas why this is happening? So sounds like it's going to be on a Yamaha, and on the VST, if you say you've got fuel seems to be coming from under the brown plastic connector. So either one, the connector is just messed up and it's leaking fuel out of that, or two, the high pressure pump inside the VST is your vapor separator tank, which on an EFI engine, fuel is pulled from the fuel tank into this tank, and inside that tank is a high pressure pump. That high pressure pump pressurizes the fuel to a specific pressure, and then that pressure is sent to the injectors, which feeds the engine. Now, inside that VST tank, that high pressure pump is got a gasket around, it's pulling fuel through the pump, and then it's pressurizing that fuel. Where that fuel pump goes up into the top of the VST, there's a gasket around it. That gasket could be messed up, and it's pressurizing that tank, the VST, and that is what's blowing the fuel out of the top of it. Or it's just got, that connector's broken somewhere. Something's broken, an O-ring has failed around the connector, and the VST's filling up, and it's just leaking out of there. If it was spraying out of there, I would say it's the fuel pump, but since it's just leaking out, it's probably just cracked, broken, something like that. So I would look into, you've got it. Just take that VST apart and pull that thing out and look at it. You'll probably see a broken O-ring, the plastic being cracked, or the gasket around the high pressure pump is messed up. So That's what I'd be looking at there. Kuda says my 1982 Evinrude 2-stroke 60 horsepower, also older than me, over revs when I take it out of the water to flush it. It just starts revving really high when it is in the water. When it is in the water, though, it is completely normal. Got any solutions? I wouldn't think too much about it. If you said, like you said, when it is in the water, it is completely normal. Nothing wrong with it. So I wouldn't be worried about it. What's most likely, I'm not sure how high you are saying, really high. It probably sounds a lot higher than it really is just because it's a 2-stroke, it's out of the water, and it's going to sound and feel like it's a lot because it's not in the water. But most likely what's going on is back pressure. So you've got an engine, whenever you put it in the water, there is back pressure, which means that the exhaust on an outboard comes out of the propeller, but it also has a above the water exhaust where it will allow, exhaust to go out above the water. At idle, because you've taken the lower unit, being the exhaust that comes out of the propeller, that is submerged in water. Whenever this is the water, whenever you submerge that, the pressure of the water creates back pressure on your exhaust, on your propeller. That back pressure is what is changing the idle of the engine because the engine can't get rid of the exhaust. It's trying to get rid of the exhaust. You now have back pressure on the propeller, so it's resistance basically on your exhaust system. That's why there's above the water exhaust to relieve that exhaust and let it go out. Whenever you have the engine out of the water, there is no back pressure. So that means it's a lot easier for the engine to get rid of the exhaust, which means that in the water, that back pressure, your idle is set in the water. Your timing, everything is set to be in the water with the back pressure on the prop. So the idle is going to be, set, let's say it's set at 750, 800, depending on, a 1982 Evinrude 2-stroke, my guess is it's idling somewhere around 800 RPM with back pressure. Take that engine out of the water, no back pressure on it. That thing might be idling at 1,000, 1,100 RPM because there is no back pressure and it's just blowing that exhaust out, and it's just a lot easier for the engine to run, so it's going to bring the RPM up, which out of the water, it's going to be extremely loud and it's going to feel and sound like it, like it's really, really high RPM. My guess is that's all you're talking about, so I wouldn't be too concerned about it. If you've ever got your engine in the water, everything running fine and no problems, most of the time it's leave well enough alone and don't mess with stuff that's not broken. Mickett says, okay, 08 V-Rod 200 4-cylinder. So we're talking about a 2008 Mercury Verado 200 horsepower 4-cylinder engine. All runs fine, but turnkey on, engine off, and pump keeps running and running. No alarms or smart gauge alarms. Motor works as it should, lots of power, and runs fine. Any idea why I believe high pressure pump would be running continuously with key on, engine off? So this is an older engine. The Verados came out in late 04, early 05. So between 2004 and 2008, the Verado went through a bunch of changes. It was a flagship engine, went through a lot of changes. On the 2-cylinder, there's really two reasons why that fuel pump would still be on. One is the way it's wired, being like a mechanical thing, or two, the way it's being operated, being a software thing. Most likely, I have seen issues where the fuel pump would run because someone had it wired hot. So, with the key on, it is supposed to only turn on for a few seconds. Let's say 6 seconds. You turn the key on, the fuel pump should turn on for, say, 6 seconds, which would pull fuel from the fuel tank into the FSM, and then it would pressurize that fuel. So both fuel pumps would come on for, say, 6 seconds at key on to pressurize your fuel injector. So that way, when you go to start the engine, it's got pressure made, so it'll start and run easy, no problem. If it didn't do that, the engine would have trouble starting. Now, if someone has wired it to where, let's say they had a problem with one of the pumps and they wired it straight, then that would, it would tell that pump to be on whenever the key was on. So that is one option, most likely not your issue, but also I know there were a few years where there was flashing issues with the 150-200 that 4-cylinder. Everything is on a count system, meaning that everything runs for a specific amount of time based on the software or the flashing of the engine computer, the ECM. Now, normally, the counts would be, let's say, 6 seconds. So however many counts 6 seconds would be, that's how many counts it would be. There was different flashes and, software updates that affected this. Sometimes it would be an issue, and it's kind of hard to, I'm kind of like describing it incorrectly, but the flashing of the computer would affect this. And I don't remember if it was the high pressure pump being on at key on or not, but I know there was other flashes where the lift pump timeout and how long it turned the lift pump on, that affected it. So I don't know if the key on is a flashing issue or a wiring issue. Those are the two things that I would look at. I would probably most likely leave it alone unless if you take it to a dealer and and there is a flash available for the computer, I would reflash it. But other than that, I would probably not mess with it. I would just think the key on, the fuel pump's going to be running, so don't leave your key on unless you want to leave your key on for some reason. Then in that case, but yeah, I would say that it would have one of those options being the issue, either the flashing or somebody's wired it up to where that pump is running all the time. Roco says, pretty cool explanation. I have one question. Optimax 225 on the max throttle boat shoots like an arrow, but runs for maybe 30 to 40 seconds and then starts to cut. And if I lower the throttle, then can continue to go, maybe 4,000 RPM. Then nail again, throttle, and again runs wide open for maybe 5 to 10 seconds and again starts to cut. To my eye, seems like simply don't have enough fuel to run the max throttle. Spark plug are brand new, and engine is actually really explosive, but for like 1 minute and then it starts to cut. Going intermittent. I lowered down a bit throttle and continue to go on less power well, smoothly, and without interruption. Low pressure fuel pump, maybe. Thank you. On your Optimax, Roco, I'm saying that, yeah, you're definitely right. It's a fuel issue. It sounds like a fuel issue, especially when you can go wide open throttle for 30, 40 seconds and then it starts to fall on its face. So that means that it's got fuel, and then boom, it doesn't have enough fuel, doesn't have the volume of fuel, doesn't have the pressure of fuel. So based on that, you need to kind of go through your fuel system, whether that be the screen on the bottom of the high pressure pump is dirty, you got a fuel filter that's dirty, that's not allowing the volume of fuel to get to the VST, or whatever the case may be. My guess is that it is from the VST to the injectors, not pre-VST. And I say that because you can run actually, no, I can't say that because, yeah, if you've got a dirty fuel filter before the VST and you run 30, 40 seconds, I just find it hard to believe that it's going to consume that much fuel that quickly. If it consumes the entire VST in 30 seconds, that's a lot of fuel really quickly, though I guess I've never really even thought about how much fuel is really being consumed at wide open throttle. We all know like that engine, you might be burning 25 gallons an hour at wide open throttle, but what does that mean per minute? Like, how much are you burning per minute? Is that an entire VST canister full? Possibly. Not 100% sure. So you need to go through the fuel system, basically from the tank to the injectors, because it very well could be. It could be a dirty fuel filter that allows you, the low pressure pump, to pull enough fuel to fill the VST, and it can keep up with the amount of fuel you are consuming at 4,000 RPM. But as soon as you go wide open throttle, it cannot keep up with the amount of fuel the engine is consuming at that higher RPM. So that could be a dirty filter, could be a dirty VST filter, could be a dirty filter on the bottom of the pump, the low pressure pump or the high pressure pump. But now that I just talked it through there and thinking about it, it sounds like, yeah, you're running out of fuel. The low pressure pump, most likely on the outside from the tank to the engine VST, it's allowed, it can pull enough fuel to fill the VST to run 4,000 RPM consistently for however long you want to run it. But as soon as you start consuming more fuel than you are at 4,000 RPM, then the low pressure pump is not able to keep up with that same volume of fuel, because the amount of fuel it's putting into the VST, you're consuming it quicker than you're putting it in. So, yep, it's a fuel issue. Dirty filter, dirty pump, dirty, water separator, whatever it could be, any one of those. I mean, it could even be an issue with the pickup, where the pickup has got a clog in it and it's only allowing so much fuel to go through. So, yep, you need to go through your fuel system. Catherine Ramiro, I have twin Merc 2016 225 3.4 liter. They don't hold RPM. If cruising at 3,600 RPM or in that range, they will vary from 3,400 to 3,800. I assumed it was the FSM, so I attempted to rebuild it using your video and directions. I was wondering, what is the procedure for bleeding air out of the fuel rail? I was able to get fuel in the FSM, then had wife put key on position while I cracked/pushed the Schrader valve. Did it about 3 times, both sides. Motor fired up and ran for a while, then ran rough. I squeezed primer ball. It was a little soft and it smoothed out, but watching the tack and idle, it would vary 540 to 600, but appears fine. Is that okay? I haven't sea trialed. Want to do starboard FSM. Thank you for your help and awesome video. Thank you, Catherine, for checking out the videos. But as far as the process, you had the process down. You turn the key on, turn the key off. Again, back to that 6 seconds, the low pressure pump turns on and the high pressure pump turns on. You're pushing those Schrader valves down and it's going to be pushing air out of there. And then once you get fuel into the fuel rails, then, you would do exactly that. I mean, another way to do it too is if you push the Schrader valve and prime the primer bulb. Sometimes that works, but key on, key off is the way to go. Once you start and run the engine, you should let it idle for a few minutes. At 30 seconds, a minute, 2 minutes, it's going to run rough for a while until it gets all the air out of the system. So I don't know how long you let it run, but you basically had it as far as, priming it up, letting it run. The variance of 540 to 600, though, that is a decent swing, but I don't know if it's enough to be concerned about. Generally, those they're pretty steady, but again, you got a lot going on there, and there is no back pressure on the prop. So as long as you're not seeing any fuel on the ground being in the water, meaning that you didn't put the FSM back together correctly, then yeah, I would put it in the water and check it with back pressure and see what it does in the water after you let it idle for a little while. Now, as far as 3,400 to 3,800 and being an issue in your cruising speed, that could have been a variable in the FSM and the fuel pressure, but also, what was it doing in wide open throttle? That would be my next question, is what's going on at wide open throttle? Is it fine at wide open throttle and only has an issue of it looks like a hiccup of some sort at 34 to 3,800 RPM? Because if it does, there could be another issue going on there, whether that's, it's dropping out spark or it's, doing anything like that, because a 2016 225 3.4 liter V6, some of those did have wire harness issues where the ignition system that controls your coils, the wires would rub and it would rub a mark in the wire, and then you would have bare wire, which would get corroded, and then you would be having issues there. Generally, it was pretty instantaneous of, losing spark and getting codes at that point in time. It wasn't necessarily just no codes and having an issue, but there is a potential for a different issue there as far as 34 to 3,800 RPM or 3,600 RPM cruising, and it being so changing RPM so much, because that's 400 RPM is a lot of RPM to be changing when you're just cruising. So hopefully it worked out with the FSMs, but you pretty much had the process right. One Chosen 24/7 just had an incident with my Yamaha F150. I was on the way out on a trip and felt a loss of power, so I went to neutral to check the engine, and as soon as I came to a stop, I saw smoke coming from my cowling. Turned the boat off just as the warning sensor came on. After pulling the cowling, I saw some oil spray on the engine was causing the smoke. So I got towed in. Once I got towed in, I saw one bolt came loose from the manifold. Now I got a clanking noise coming from the engine after fixing the bolt issue and refilling my oil. So this does not sound good. This sounds pretty bad. So two things are going on here that are potentially an issue. So one, the oil spray. So the oil spray onto the engine and creating smoke. If the engine got so hot to where oil being put on the engine burned the oil and made it smoke, that engine got ridiculously hot. So we've got an overheat issue going on here, is right out the gate. That's what I'm looking at. I'm looking at an overheat issue because you got smoke. I mean, oil's coming out, getting on the block. The block is so hot that it is burning the oil. So that's a problem. One, if it was a cooling water issue, like let's say you wrapped a bag or you got something around the lower unit and you lost cooling water as you're, idling out or whatever, you're running out and the engine started to get hot. Generally, your overheat alarm is going to go off before the engine has a chance to get hot enough to where it's going to burn oil. That is, one thing. I guess it is possible to get hot enough without sounding the alarm to burn the oil, but by and large, if it was cooling water and you wrapped a bag or something like that and started to overheat it, generally the alarm goes off before it gets too hot and causes, catastrophic damage. If you had a loss of oil though, like this bolt being loose on, you said you noticed, once I got it towed home, I saw one bolt loose on the manifold. So, on the intake manifold, if it's on the intake manifold, that's not really going to be, the intake manifold isn't going to be an issue because that's just going to give you an air leak. A loose bolt on the intake manifold means that you would be sucking air. You would probably have an elevated or higher RPM, but you would not generally have, an oil leak. So where's the oil coming from? That's going to be the main concern. So if you've got an oil leak that's bad enough to where it dumps enough oil out to where the oil went low and you overheated from lack of lubrication, now we've got a serious issue. Like now we're talking, most likely that's a serious concern. And now that you've filled the oil and you've tightened up this bolt, now was that bolt on the valve cover? And you said manifold? On the valve cover, that's different. You can dump, if the valve cover comes loose, a bolt was loose on the valve cover, and you've dumped a bunch of oil out of the engine, I would hope that you would have noticed that much oil in the water. As soon as you put the boat in the water and start and idle it, like if it's got a loose valve cover and it's dumping oil out like that, then there's going to be oil all in the water. Like you're going to have a massive sheen. You're going to see it. It's, going to be super noticeable, but maybe you didn't notice it, or maybe that wasn't really the case. Seeing that you had to fill the engine with oil, that means that oil was very low. So in the case of the lack of lubrication and getting hot because you lost a bunch of oil, now you've got a clanking noise coming from the engine. None of those are good, my friend. None of those are good. And you need to get, I wouldn't be running that engine for one, if it's clanking. Don't run the engine, do a compression, do a leak down. You need to see what the actual mechanical numbers are of the engine and how it's performing, because you might have a serious issue. The engine got so hot that, something it sounds like the engine got overheated, and for whatever reason, whether that lack of oil or lack of cooling, it has caused a major issue, and it needs to get checked out, because if you keep running the engine, especially if it's clanking, even if you can get it running and it's making a clanking noise, you go out and use that engine, I mean, you're very likely to blow it up. So I would definitely get that checked out. Unfortunately, I'm sorry, but it sounds bad. So I guess just everybody, pay attention to the temperature of the engine. Ivan Slavos says he's got a 2004 Boston Whaler with an Optimax 135. Cruising at 4,000 RPM and my Garmin's flickered and restarted. I stopped, went to neutral, engine was running fine. I saw fault fuel level on SmartCraft gauge. I restarted the engine, moved my battery switch off and on. Hopefully you didn't move the battery switch off and on with the engine running. Don't do that. That's not good. Switched to my second battery and kept going 5 minutes later. Same thing happened, so it was a battery-related issue. Blah, 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 blah. I later realized that this is not the case, as the same thing happened after I docked the boat and tilted the engine. Turning on the battery switch would not even start the electronics. I went the following evening trying to measure the voltage and troubleshoot, moved the battery switch, and now everything is working. I ordered a new battery switch, Perco 8501, replaced it, and was hoping the old one to be rusty with visible signs of problems. I had to cut it open and see the contacts, and contacts are as clean as new. I am so baffled now, as I have to prove, because I have no proof the switch was the issue. And are there any tips that you can give me in terms of what else to check? Thanks in advance. So Ivan, I would be looking at those batteries. If you cut open that battery switch and everything looks good, for one, when you took the battery switch off on the back of it where the cables are attached to it, I'd be looking for a loose cable, and I would be looking for green, dirty connectors. If the connectors were not green, they were not dirty, everything looked good, they were tight on the back of the battery switch, it's unlikely that the battery switch was the problem. But without tearing it apart, you could have just taken your meter, did an ohms test, and checked the resistance between them, like with it off and with it on. And, that would have been enough to tell you if the switch was the problem. Sounds like the switch was not the problem, but I would be looking at those batteries. How old are those batteries? How charged are they? Are they serviceable? Like, are they a maintenance-free battery, or are they a maintenance battery? Are they low on water? So, you need to top them off with water, charge them up. I'm looking to those batteries before anything else. As long as your batteries are good, then we're looking at those cables, like the cables from the batteries to the battery switch, and then also from the switch to the engine and to the electronics. I'm more condemning the batteries before that, because generally you don't have the same issue with two different sides of the boat. With, because you got four different situations. You got one battery, two battery, one engine, one house, all your house stuff, your electronics, Garmin, all that stuff. So you've got four different components here, and the likeliness of, the two separate systems being an issue at the same time, because your battery switch is the only link between the two, then my guess is that the battery switch is not the problem, but the batteries themselves are what connects to everything, because based on which position you put your switch on, the Garmin's are consuming this power from the same battery, and the engine is consuming power from the same battery. So my guess is you got a battery issue, or the cable's going from the battery to the actual battery switch. Other than that, it could be a ground issue. But again, like, if there's a ground issue on the engine, generally you're only going to see an engine issue and not necessarily an issue with your Garmin's, depending on how your boat's wired. I got no idea how the boat is wired or what the wiring looks like. A 2004 Boston Whaler, my guess is the wiring, if nothing has happened to it so far, it's probably pretty shoddy right now. Like, being a 20-year-old wired situation on a 20-year-old boat. How long have you owned it? You've got two Garmin's on there, so somebody's been in there installing electronics. So who knows what that wiring situation looks like. But to have the engine issue with the Garmin issue, the ground to to the engine should be its own path to the battery, and the ground to your Garmin's or all your house electronics should be its own ground to the battery. So you've got two different systems. Problems with both systems tells me that the battery is the issue, though depending on the wiring, it could be something else. So yeah, check them batteries first, and then if the batteries aren't messed up, then look at the grounds going from the battery to the engine and to the house stuff, and then after that, then start looking at your wires going from the battery to the switch to your components. Most likely you've got some old batteries though. Randy says, I know I am late. What could be causing my 40 horsepower two-stroke Mercury to be bogging down at full throttle? Well, Randy, all that information that you gave us, it could be anything. It could be bad spark plugs. It could be lack of fuel. It could be no spark being the ignition coils. You could have a stator issue because it's a two-stroke. You could have a carburetor issue because it's not getting fuel. You could have all kinds of stuff. Generally, when someone says bogging down, that means that you put it into full throttle and the engine gets up to full throttle and then just bogs down like it just bogs down to where it's, barely going on, boat comes off plane and the engine just starts shaking. Generally, that's a fuel-related issue, and you've consumed all the fuel, and now it's not got enough fuel. The timing is advanced, thinking that it's getting fuel, and so it's just shaking and running terrible, and you're not getting fuel. So if your engine's bogging down at full throttle, start looking at your fuel delivery system being from the tank to your carburetors, because you said it's a 42 stroke. My guess is you've got carbs on there, and it's got an issue with that, or the fuel pump's messed up and the fuel pump is leaking fuel into the crankcase. That's bogging it down. It could be so many different things. It's not even funny. So sorry, Randy, I ain't got much more information than that. That's kind of where I would go, is look for fuel. Bogging down generally means fuel. Philip said, I have a Yamaha 115 four-stroke. Is it okay to drive for 1 hour at 4,000 RPM? Yes. I don't know what else to say there, Philip. 100%. A Yamaha 115 four-stroke, 4,000 RPM is cruising speed. So I don't care what engine you have. I mean, pretty much every outboard should be able to run for however long you want it to run at 4,000 RPM. Granted, I mean, 12, 10 out, once you get into that amount of time, generally you can't do that anyway. But, yeah, an hour at cruising speed, you should be able to run for long time. No problems. So I won't end you on that one. We'll do one more from Paul. Paul says, okay, Paul, you got a lot going on here. Suzuki DF50, my telltale was not peeing intermittently. I tilt the motor full down and it streams out. I determined it was the head gasket. After I replace the impeller plate, key, and gasket, it pees under a water hose, but not on its own at idle. Replace the head assembly. Yep, valves and all. That's a lot. That is you've gone way too far. Rebuild fuel separator and coolant. Replace all the hoses, tees, flush the foot forward and back. Replace the water pressure valve that is under the oil pan. Pulled all anodes out and flush motor on and off. Flush the motor with on and off, I'm guessing. Still intermittent P stream and steam outs at idle 900 RPM. Still same problem. Seems like the exhaust still intermittent P stream and stream outs at idle 900 RPM. I'm not sure okay, so still same problem. Seems like the exhaust pressure is pushing the water out. When does the exhaust enter the water chamber? Could excessive exhaust pressure keep the water from pressurizing the head? Next step is to backflush the system through the P hole with rid lime and hope it is a salt pack buried deep in a casting. If I take off the gearbox foot and attach a hose to the pickup tube, I get a 3 to 4 foot P stream under impeller. On the best day, I get half a foot. I have owned this motor since new and have always had a 2 foot P stream, even at idle. I am completely stumped. I have done all the easy steps. You've done all the hard steps too. I mean, you changed the entire head assembly. That's a lot, Paul. So, just to kind of get an idea of what's going on. So on the hose, like when you hook the hose up to that engine, you're putting 40 PSI of pressure, generally is what hose pressure is, into that engine. It's going to be great. The impeller at idle is going to be making 1 to 2 psi under idle. At wide open throttle, it might be making 15 to 20 on a DF50. On like a 300 or 400, that impeller can make 25 psi. So your pressure at idle is 1 to 2 psi, which means it's not a lot of pressure. Now, starting from the beginning is where you got to go. Just like we were talking about the flywheel issue earlier, and starting with the flywheel to get to the spark plugs, same thing with your water flow. You want to start from the beginning, being the impeller. So the impeller and all that, you said new plate, new gasket, new impeller. But then the only thing you didn't say is the water tube. So from the impeller to the engine, it goes through a water tube. The water tube has a gasket on the bottom and it has a gasket on the top. A lot of times, especially on smaller engines, a 25, 30, 40, 50, stuff like that, these engines at the water tube at the top where it goes into the power head, that water tube has another gasket up there. And depending on how old it is, salt, corrosion, that kind of stuff, it could have an issue where that rubber grommet, it starts squeezing in on the tube and you get buildup around that. So when you had the power head off to look at the, to change out the head, you should have looked for that water tube where it goes in. I don't know exactly on a DF50 where that goes in. Most likely it goes in under at the top of the drive shaft housing, the bottom of the adapter plate, oil pan housing, whatever, that section there between the oil pan where the block sits on the oil pan, adapter plate, drive shaft housing, whatever you want to call it, that right there, and the bottom of that, somewhere in there, that water tube connects. And there's going to be a rubber grommet, an O-ring, something there around that water tube. I'd be looking at that spot there because most likely, I think, not 100%, but it might go from there into that water valve assembly, like you were saying. It's on the side. It's on the, I'm not sure if it's on the port or the starboard side of the engine, but there's that water valve assembly, whatever, the water plug, whatever they call that thing. There, I think it goes into there, and then it goes to the power head. So I'd be looking at that right there, that water tube, top of the water tube. That's what I would be looking at because you've done everything else. So my guess is something is going on there. But again, at idle, remember, you're only getting 2 psi of pressure. So it's not going to be, this crazy stream. At wide open throttle, that's going to be a lot different. But that's kind of the difference between the hose and the impeller. And yeah, my guess is check your water tube. Most likely there's something going on with that water tube. If not, it's the best I could think of. So I wish you all the best of luck, Paul. I hope you get that figured out.